Okay, this is 5.1 notes, and this example 2 was A and B was review. So we are rewriting each of the following expressions as a single exponential expression in the form a to the m. So what we're practicing is that you can't use the exponent rules if the bases are different. So right now, the 25 and the 5, you can't combine them because they don't have the same base. That's the key to using all of the exponent rules. They have to have the same base. So you have to think in your head, how can I create the same base or equal bases? And this is going to be practice to our big lesson on example 3 is what we'll get to. So here's an example already done, and then you should try this one. Now we have you should just pick the smaller number, right? So the smaller number is 2. So you think, how can I rewrite the 8 with a base of 2? So how do we rewrite 8 but make it a base 2? It's going to be 2 to what power? To the 3, good. And that's over 2 to the 3x minus 6. So pretty much every time you do that, the next step is you're going to have to distribute that power that you just wrote down. So that power was 3. So we're going to distribute that 3 to the 2x minus 1. So let's see here. 3 times 2x, 6x, and then 3 times negative 1 is minus 3, all over 2 to the 3x minus 6. Okay, what was that step? We did 3 times 2x times negative 1. Okay, this is a division now. So what is the rule for when you divide the same base? What are we going to do? We're going to subtract the exponents, and what do you need to be careful of? We need to be careful of distributing that negative sign and making sure you're subtracting each term. We're going to need 2 more steps here. Let's see. We have one single base now, and we're going to do 6x minus 3x. So 6 minus 3 is 3x. Okay, now we have a negative 3 minus negative 6. Negative, if you have to write that down, that's okay. What's negative 3 minus negative 6? Positive or negative 3? Plus 3. Do you see what do the double negatives make? A plus sign. Yeah, negative 3 minus negative 6. Okay, do we see this root? Yeah, and we have a power. So what do we do with a power and a root? Power's on the top, root's on the bottom. So the power is 3x plus 3, and the root is 3. We go back and make this official. Okay, then we look at this power divided by the root, and can we simplify? Yes, so we have 2 to the x plus 1. All right, that's our little warm-up. Are you guys warmed up? You ready for the real lesson? So the whole point of this lesson is right here on example 3. Are you excited? I know it, I know. Okay, rewrite. Ready? We're going to rewrite each side of the following equations. What? We have equations now instead of expressions as a single exponential expression with the same base. That's what we've been practicing. Okay. Then, what? We have a new word here. What does this say? Solve the equation. Everyone say solve. Solve. Have we solved anything lately? No. We've just been like simplifying and rewriting and evaluating. You ready to solve? All right, there's 2 steps here. So what was the first step? Rewrite each side of the following equations to a single exponential expression with the same base. Can we do that? Here we go. You have 27 and you have 9. 27 and 9 come from what same base? 3. That is excellent. So 27 is 3 to what power? To the 3, good, or cubed. And what's 9? 9 is 3 to what power? Squared, right? So that's step 1. Rewrite each side of the following equations as a single exponential expression of the same base. How did you know this? You have those memorized, okay? Memorization quiz coming up. If you didn't have them memorized, you would be just lost. You wouldn't have any idea what you're doing. Do we have the same base? Yes? Okay, guess what, you guys? This is so much fun. Ready? Solve, step 2. Solve the equation by what? Setting the exponents equal to each other. What? I'm just going to do what it says, okay? Those are the rules, right? It's printed on paper. That means it's fact. Set the exponents equal to each other. What the heck? What happened to the 3's? Okay. The 3's. Did we cross them off? No. Do they actually physically cancel? Not really, okay? They don't really cancel. All we did is made sure the base was the same. And then do you agree that if the bases are the same, the exponents have to be the same? Yes? Because what's right here? What is this called? An equal sign. Okay, so you know what? We're using these 3's. We're using them to get what we want, and then we're throwing them out. All right? Have you ever used someone to get something? I hope not, but today's the day for you to use someone. Okay, ready? Can we solve this for x? Oh my gosh, this is so silly, right? This is just a linear equation. And we're going to go quickly so that we can get to another example where the change of base might be a little harder. Let me know if I've made a mistake, but I'm going to go quick and then I go back and check and I subtracted the 3x, then I subtracted the 10. I think that's right. What do you say? You guys agree? Okay, what do we do when we're going on to B? Ready? When we have a fraction, that means we're going to change base, but our exponent's going to be negative, okay? You tell me, 4 and 8. 4 and 8 are going to share what same base? What number? Don't think too hard. 4 and 8 share the same base of 2. My equal sign is totally not in the right position. Okay, but do you see how this is 1 over 4? That means it's 1 over 2 squared. So we're not just going to put 2 squared. What do we need to do to it? We need to make it negative. Why is it negative? Why? Tell me again. I just told you the answer. I'm just seeing if you're awake. Why is it negative? Because of what? Because it's a fraction, okay? Or it's in the denominator. What's the 8 going to become? 2 to what power? 2 to the 3. Here we go. Our base is the same. Okay, now that the bases are the same, you've used them. Do we need them anymore? No. So what do? Set the exponents equal to each other. I know it's so silly. It's like you want to cross them off. You need a purpose for those 2's, but they have served their purpose and we don't need them anymore. Okay? Go ahead, you try. Solve for x. It's not a traditional answer, so I want you to try it. All right, I gotta hurry in order to fit in the last 2, but this final answer, oops. Doesn't it feel good to go back to solving linear equations? You're like, I remember you. Where did you go? You used to be so hard, but now you're so nice. 8 over 5. Okay, ready? Tell me what the same base is going to be. It's going to be a base of 2. So this 4, don't worry about that root. You know, we kind of like to keep it along for the ride for a few steps. That's okay. This one already has a 2. Should we distribute that 3 now? We can, right? Let's do that so that it's ready. It's ready like that. Okay, we have a power and a root. So power on the top, roots on the bottom. I taught my 7-year-old that today, so he's ready for high school. That's our power. What is our root? What number is there when you can't see a number? It's a 2. The right side's just going along for the ride for a few steps. And what do we have here? I didn't distribute that 2. Kind of by accident, but what happens to these 2's? Yeah, they do divide out. Now, do I need to write a whole nother step with the 2's? No, we're ready. Yeah, we have the same base now. Yes. So what do? So we're setting the exponents equal to each other. And then solve for x. Pretty nice of this worksheet to not give us any quadratics to solve here. But could you see if we had an x squared that a quadratic equation could appear? Yeah. But that was nice of them. The math gods are in your favor today. -4. Howdy. Here we go. Do you guys like this lesson? I think it's fun. And then guess what? You'll never see it again. Okay. I know you want to say the base is going to be 4. I know you want to say that, right? You want to say 4. That would kind of make the right side easier and the 16 easier. But can you say 8? Can you express 8 as a base 4? No. So we have to go all the 2's. So let's do the right side, the easier side first. 2 squared. Y'all agree with that? Okay. And then 16. 16 is 2. 8 is 2 to the 3. So 16 must be 2 to the what power? 2 to the 4. Isn't that beautiful, all those 2's? I'm trying to think, what do we need to do here? We need to subtract these. Should we distribute them first before we subtract? Yeah, let's take a step to distribute. 4x plus 8. 3x minus 3. We could distribute this right now. 6x plus 2. Okay. When we divide the same base, we need to subtract these powers. You ready? Here we go. Single base, 4x minus 3. I was going to say 7, but it's only 1. Need more coffee. Ready? Every single time we're almost having this, right? 8 minus a negative. 8 minus a negative is going to change it to positive, a plus sign. So 8 plus 3 is 11. Awesome. Now do we have the same base equal to the same base? So that's the step, you guys, right there. When you have like a 2 equal to a 2 or 3 equal to a 3, then you know you're ready to get rid of them. They've served their purpose. And we're going to set the exponents equal to each other. And the countdown's on. Countdown's on. Here we go. 11 minus 2. I have the number 9 equal to 5x. If 9 equals 5x, then x equals 9/5. Awesome. After watching this, you're going to do the practice on the next page, and that's your homework. Thanks for watching.